Hey everyone, this is me again. Now in the previous video, I already gave you a summary of all the reactions that you have to learn for alcohols, right? Altogether, the 6 reactions. They are the combustion, substitution, nucleophilic substitution reaction, and the reactions with sodium metal, acidification, dehydration, and oxidation, right? So now, in the meantime, I'm going to go through each reaction with you with several video clips. Okay, I don't want to put them together to make one video so long. I will need you to take out this handout. I bet you already checked all the answers because I already posted all the answers on the Saturday. So since we are having the answer and the natural notes, so I will go through them quite fast. Okay, so please bear with me. Now for this page, of course we already learned this page, so we can go on. What happened? You can go on. Okay, let's see this one. Okay, here. Okay, combustion. This is the first reaction, combustion. Now take a look. Okay, combustion. When you burn something like alcohol, in excess oxygen, carbon dioxide, and water will be produced. This is the reaction we have talked about for a lot of time. Okay, and bear in mind that if the combustion is complete, so the color of the flame will be blue. Okay, will be blue with a good supply of oxygen. So let me try to highlight it. The computer is very strange because when I want to write, I can't magnify the image. So anyway, you have your lecture notes, so I bet it's easier for you to follow, right? And then here it's talking about, it mentioned that sugar canes can be fermented to make alcohol. If you're a biology student, you should know that. But one more point I'd like to point out is we say that sugar cane, we say that ethanol is regarded as a carbon neutral fuel. The idea is if you produce ethanol this way by fermentation, when the sugar cane, when they grow, okay, they absorb CO2 by photosynthesis. So even though during fermentation they produce carbon dioxide again, it's like a zero-sum game because they help absorbing the CO2 during growing, and when they undergo fermentation they give out carbon dioxide, so the net carbon dioxide produced to the planet Earth is zero. So that's why we call them as carbon neutral fuel. Okay, now these are the reactions. Here are the reaction that we have been written for a lot of time. Carbon dioxide and water, remember to balance it. Okay, remember, of course, if you don't want to use a fraction, you can magnify the whole equation by 2. But if you're asked to write a thermochemical equation, remember to maintain this one. Okay, this is what I told you. Okay, the classwork. Glucose can be fermented with yeast in anaerobic condition. Anaerobic means absence of oxygen. Absence of oxygen. Okay, I bet you learned this in your biology. Name. Now remember in the exam, name. Come up with carbon dioxide and ethanol. Do not come up with the chemical formula. Okay. Oh. Okay. Let me see. Okay, substitution. Now this is what I want to tell you. Substitution reaction. Now same as the halogen alkene, the substitution reaction that alcohol has is also nucleophilic substitution reaction. Okay, so as I mentioned in the previous video, substitution reaction basically is okay, right here. Okay, so for example, if you have an alcohol, right, and then if you add HX, right, then we are expecting this OH group and this X will be replaced with each other, right? So the RCH2X will be deported. This is called substitution reaction. And the mechanism, okay, for the mechanism here, you don't have to know. how to draw the mechanism for alcohols. Okay, now but for halogenic alkene, you also have to know when is SN1, when is SN2. But here I can also show you because I don't think it's that hard. Okay, so let me see. Choose something more. Anyway, I can show you. For example, stupid. CH2 OH, right? Reacting with HCl, okay? First, you know that this bond, what happened? Okay, so is polar, right? So, what I'm going to say is this lone pair electron is going to capture this H, and the bond of HCl will be broken. Then what will be happening is it become and this one, okay? The reason for that is after this OH group captured a H, it becomes this group, right? And this group will be a very good leaving group. I think I told you in the class before, which means it's very easy to, this bond is easy to be broken, okay? So the next step, I think you can guess it, right? This lone pair electron is going to bond with this C because this is delta H, and this bond will be broken, okay? So what will be happening is it will become RCH2 Cl plus. When this bond is broken, these two electrons will go all the way to oxygen, and then making this group become a neutral water. So that is basically the mechanism. Can you see that? First is the capture of a hydrogen, capture of this hydrogen with this lone pair electron, okay? And then to make this OH group become a good leaving group by bearing the positive charge, then the Cl minus the lone pair electrons will attack this positive carbon and the whole group will be broken. So the substitution reaction is this way. Okay, understand? Oh, now we go back to the notes here. Now, as substitution reaction, if you take a look at the notes, I already told you there are several reagents you can use, right? You can use HCl, and HCl can be produced in situ by reacting with a sodium chloride, the salt, together with concentrated sulfuric acid and non-volatile acid. You learned this in the chapters of halogen, do you remember? By means of situ, it means you put everything together so that this thing, and this thing together in the reaction fast so that they react together. When the HCl produced, it would directly react with this one in the reaction fast. Okay, this is called in situ. Okay, and then you need to heat it under reflux now, right? And then at the end of the reaction, you have to distill off the bromoethane you produced, and you need to know how to draw this diagram. Okay, so as I told you, you can choose to use HCl. HCl is your first reagent, and HCl can be produced by reacting NaCl and H2SO4 in situ. But if you just react ethanol with NaCl, there is no reaction. Do not be trapped. Okay. Oh, anyway, we go to the next page. Now this page is talking about if you don't want to use HCl, as I mentioned in the previous video, you still have other reagents you can use. You can use SOCl2, okay? And the reaction is here. Remember, this is the product you want to have, right? Organic product. And these two are the byproducts. Since both of them are gases, they will be just gone. So you don't have to distill the product out, okay? Now in the exam, I have to remind you again, when the question asks you to state all the products, of course you have to include HCl and SO2 as well. But when the question asks you, for example, to name the organic product or to come up with the chemical formula of the organic product, then only chloroethane here is included, okay? Oh, now if you don't want to use SOCl2, you can also use phosphorus halide. like PCl5 and PCl3 are two reagents you can also use. For PCl5, it is more reactive than PCl3, so it happens at room temperature. But if you use PCl3, please apply heating. Now, both of them can help you to obtain the same organic product, chloroethene, but the byproducts are different. So you will have to recite these two chemical equations. Okay, do you understand? For PCl5, it comes up with HCl and POCl3. However, if you use PCl3, it comes up with H3PO3. So, are we clear? Right now we covered combustion and nucleophilic substitution reaction of alcohols with HCl, SOCl2, PCl3 upon heating, PCl5 at room temperature. Okay, let's just stop here. I will make more videos to cover the rest of the reactions later. Work hard. I keep a very close eyes on all of you.